Right, we're going to look at finding the length of interval. This is a brand new topic we're starting today. So this is the first idea we're going to look at, finding the length of an interval. Okay, so how do we do that? Well, an interval is just, let's define what an interval is. It's just a straight line joining 2 points. So here's my 2 points. Might call this point A and this point B. So we would talk about the interval AB. Okay, now it's different from a line. A line goes forever in both directions. This is line AB just here, right? Because it goes through the 2 points in forever. So there's A and there's B. Okay, so interval AB is different to line AB. Okay, interval AB is just this part here, right, between the 2 points. So how would we find the length of that? Well, the good thing is we can use something you learned back in year 8, and that is Pythagoras' theorem. If I draw a vertical line and a horizontal line from B, there we go roughly, and there's a right angle, then I can use Pythagoras' theorem. Now, Pythagoras' theorem says label the two shorter sides A and B and label the longer side C. Pythagoras' theorem is A squared plus B squared equals C squared. Okay, so A and B will be the vertical and horizontal lengths, and C will be the length that we want to find. Okay, so that is Pythagoras' theorem. That's what we're going to use for this question. Now, technically, if I was going to stick to the strict naming conventions, A is actually opposite capital A, and B is opposite capital B there. That's the correct labeling for the sides. It doesn't really matter. The same formula still applies. C is always going to be the length of your interval that you're finding. So let's have a look at the first question. Find the distance between the 2 points -4, -2, and 2, 6. Now, I would do a rough sketch here. The number plane hasn't come out quite so nicely, but it'll do. I'll do a rough sketch of these points. So -4, -2 would be down here. And 2, 6 is up here. Okay, 1, 2, 3, 4, 5, 6. So what I then do is get a ruler, just as a sketch, and I'm going to join those 2 points there. Okay, now your job is to find the length of that interval. Okay, so that was point P, this is point Q. So what you do is you form a right angle triangle. So I'll just click on the line tool there, and let's just form a right angle triangle. So I'm going to start at one of the points and draw a horizontal line there, and then a vertical line down there to meet the two. Okay. Now, once you've done that, you mark in your right angle. All right. Now, I would label the sides A, B, and C. A, B, and C. And then I'm going to put the vertical and horizontal lengths on there. So if you count, this is 6 here, and down here is -2. So this, if you count the squares, this length here is going to be 8. So A is equal to 8. All right. And then if you count horizontally, there's -4. And just up to here is, you can see that's 2. So from -4 to 2 on the horizontal axis, that gives you 6. So if I write down my formula for Pythagoras' theorem, A squared plus B squared equals C squared, Well, A is 8, so I'll put 8 squared there. B is 6, so 6 squared there. And then C squared, well, C is what we're trying to find. We're trying to find the length of PQ, which we've used C to represent. Now, 8 squared plus 6 squared on your calculator is just going to be 100. And then you want to get C by itself. So square root both sides, you're going to get 10 for that is equal to C. So your final answer, if you like, the interval PQ is equal to 10. The length is 10 units. Okay? So in essence, form a right angle triangle, work out the horizontal and vertical lengths of that triangle, then use Pythagoras' theorem to get your answer. So copy that down, and if you like, you can pause the video and have a go at this one by yourself. Okay, so first thing is minus 2, 5. Minus 2, 5 is about here. 1, 2, 3, 4, 5. Yep, so that's P. There's 5 there. And minus 2 is there. Then you've got Q at 2 minus 2. 2 minus 2 will be 2, and then minus 2 here. So that's Q there. And now I'm just going to draw a line from P to Q. So that's the length I've got to find. And then I've got to do a horizontal and vertical line to make up the right angle triangle. Horizontal down to there. Good enough. And then, sorry, vertical down to there, and then horizontal here. Okay, so there's my right angle triangle, rough sketch. Put in the right angle triangle symbol, the corner. Now, I'm going to label my sides A, B, and C. A, B, and C. Now, if I'm going from -2, so -2 here, up to 5, that's 7 units. That means A is equal to 7. And for B, if I'm going to go from -2 to 2, there's 2 there, that means B must be 4 units across. Okay, so writing down A squared plus B squared equals C squared, you're going to get 7 squared plus 4 squared is equal to C squared. Now put that into your calculator. Obviously 49 plus 16 is what you get there, and that's going to give you 65 is equal to C squared. So you're going to square root both sides. Okay, now it says correct to 1 decimal place. So if you put in square root of 65, you're going to get 8.06 8.06 dot 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 dot, which means C is approximately 8.1 to 1 decimal place. And you should put units, I guess, because that's the length. All right, now you could also write PQ is approximately equal to 8.1 units in length. Okay. All right. Copy that down, and let's have a look at the last one. Okay. Now, last one, there is no diagram. You have to draw it yourself. So it says determine the exact. Now, this is the exact length. Determine the exact length. So no decimals. Well, it could be a decimal. Depends on the question, of course. But it's highly likely going to involve a square root. Now, let's draw up our axes. So just going to have some vertical line there, some horizontal line there. That'll do. And just doing a rough plotting of the points. So minus 6, 2. So 1, 2, 3, 4, 5, 6. Minus 6 is there. And then minus 2. Minus. So minus 2 is just there. So let's just get this out of the way for a minute. I'll make minus 6 there. So there's my point, my first point, P. Okay. Then 2, 5. So 2, 5, 1, there's 2, and then 5. 1, 2, 3, 4, 5. Okay, so roughly plotting there. And that's my point Q. All right, so what I'm going to do then is draw a line from P to Q. All right, so that's the distance I've got to try and find. So I will now do a horizontal line around about there to 2. Good enough. And then a vertical line. Okay. All right. So close enough. I'm a bit off with my picture, but it's not to scale. That's my right angle. Right, if you count the squares from -6 to 2, that's going to be a length of 8. And from -2 to 5, that's a length of 7. All right, so we're going to label our sides A, B, and C, A and B. And it doesn't matter which one's A and which one's B there, but it does matter which one is C. C is always going to be opposite your right angle, and it's going to be the length of the interval you're trying to find. Okay, so A squared plus B squared equals C squared. All right, and let's put the numbers in. So you're going to get 7 squared plus 8 squared is equal to C squared. Now, if you put that in, 7 squared plus 8 squared, you get 113. And then square root both sides. Now, what you'll notice is when you square 113, you're going to get 10.63 dot dot dot. Now, because it says exact, we can't use the decimal answer, okay? Which means we have to keep it just as the square root of 113. So that's your exact length, all right? Because we're not rounding it as a decimal. When you're rounding, you're chopping off numbers. Here we haven't chopped off any numbers, we've just left it as the square root of 113. Okay, so that is your exact length, all right? And as mentioned before, you could write that down as PQ. Length PQ is square root of 113 units. Okay, and that's it.